Alright, this is Ken Rosever. We're going to talk about confidence interval for a population proportion. Let's say you are doing a customer satisfaction survey and you are interested in knowing what percent of your customers are satisfied. So what you might do is you might sample a few of them. You probably don't have the time or money to sample them all. Perhaps you do. But let's say you don't. So you perform a survey and you get back the results. And out of those results you see 35% of your customers are extremely satisfied. And that's the one you're interested in. You know, you probably had somewhat satisfied, not satisfied, somewhat dissatisfied, whatever. You had like a whole range in there, but you wanted to know the proportion that were extremely satisfied or totally satisfied. And so that's your p hat. It is your sample proportion. It is the percent or the ratio of people out of the whole that are extremely satisfied. Once you have that, let's say it's 35%, like I said. Does that mean that out of all your customers that you can be certain that at least 35% come away extremely happy? No, in fact, it could be less than that. It could be more than that. What you have when you figure out the sample proportion is you have a point estimate of what the population proportion might be. The population proportion, your author uses the notation P for that and P hat for sample proportion. Some books use pi for population proportion because we use we use mu for the mean and we use sigma for the standard deviation, and so in keeping with that Greek thing they use pi for the population proportion because it's a parameter. But your book uses P and P hat for the sample proportion. So in our example that I'm trying to use, we have 35% is P hat, so 0.35. But P could be more or less than that, and that's where this comes in down here. In order to develop a confidence interval for a proportion, we add or subtract a amount that is determined by our confidence level, which we convert into a z-score, z-alpha over 2, and by our standard error, which in this case is the square root of p hat times q hat over n. So we're going to have p hat plus or minus this maximum error of estimate. And this little term that is added or subtracted is very important, and we'll talk about it some more in another video when we talk about determining appropriate sample sizes. However, there's one thing I want you to notice. Even though Alex won't get you with this, you should know that you are only allowed to do a confidence interval in this fashion when n times p and n times q are both greater than or equal to 5. So whichever one's smaller, p or q, you check, does n times that proportion, either p hat or q hat, does that product come out greater than or equal to 5? You should kind of remember that from chapter 6, that we're only allowed to do a binomial approximation using a standard normal distribution when this condition is met. And that's what we're kind of doing here because we're using the z, which is a standard normal curve. So let's do it. Now obviously you can use the z-chart and you should know how to do that, but I'm going to focus on the Alex on this video. You can also absolutely use a TI-83 or TI-84 calculator. The instructions on how to do that are found on page 282, and it's very simple. It's right under the stats menu. Okay, having said that, let's go to Alex. Alright, so here we go. Our first problem like this. A sociologist is studying the prevalence of crime in one major city. In a sample of 225 randomly selected residents, 81 say that they have been victimized by a criminal. Based on this sample, construct a 95% confidence interval for the proportion of all residents in this city who have been victimized by a criminal. Now, this isn't really important particularly on this problem, but if you're conducting research, the most important thing if you're doing a sampling is that it be random. Just think, if all 225 came from a certain neighborhood, well then there's no way that 81 being victimized would be in any way an appropriate point estimate of the percent for the whole city in general. It would be only a appropriate point estimate for that one neighborhood that the sample was taken from. So it's important here that they say randomly. Another thing I said is that in order for us to use that formula, n times p hat and n times q hat must be greater than or equal to 5. So we can check that really quickly. First thing, I'm going to figure out p hat. P hat is the smaller of the two, because certainly 81 out of 225 is less than 144 out of 225. Of course, if the percent that's victimized by a criminal is higher than the percent that isn't, that's probably not a neighborhood you want to live in. But 81 out of 225 is no small deal. So let's do this. 81 divided by 225. Let's figure out what p hat is. It's 36%. So 36%, and let's just do that times the sample size. Now you'll notice something happens here. What do you get back? 81. Of course you get that back, because n times p hat, think about the definition of p hat, is x over n, so of course you're going to get back x. So as long as this number is bigger than 5, you're good. And of course in ALEKS, it'll always be bigger than 5. Now that we know our p hat is 36%, our confidence interval is very easy to develop. Remember, the formula says p hat plus or minus z alpha over 2 times the square root of p hat times q hat over n. So that's what I'm going to do here. I'm going to do it all at once because that's the easiest way to do it. So I'm going to do 0.36 plus or minus z alpha over 2. Now, we want a 95% confidence interval, so alpha over 2 is 0.025. It's the 5% that's left over in the tails divided by 2, so that we only have one tail. Okay. Because you can't look up both tails at the same time, right? You're either looking in the positive half of the chart or the negative half of the chart. And so I'm looking in the positive half. Anyways, I arrow to the right, and now I hit square root, and I want to square root a whole bunch of stuff. So what do I want to square root? I want to square root p hat, which is 0.36, times q hat, which is 0.64, divided by, and it doesn't matter that it's only dividing the last term and not both of them, because whether I divide the last term or I divide all the terms, it comes out the same. And what is n? N is 225. So the square root of 225 is 15. The square root of 36 is 0.6. The square root of that is 0.8. So we're going to have 0.48 divided by 15 here times z alpha over 2, whatever that happens to be. 1.96, I think. Let's see what the answer comes out to. So the answer is, based on this sampling, let me put this over here, between 29.7% and 42.3% have been victimized. And we're doing it to 3 decimal places because they've asked us to. So we do that. And we can do that. 423. And that's our first one. Pretty easy. We check time. Alright, I think that's all I have time for in this video. I'll do another one in another video.